Hello, everyone. As Ursula already said, the focus of today's webinar will be on team considerations and also three important steps of the review process: study selection, data extraction, and risk of bias assessment. It's really great to see that people are interested in how to do rapid reviews and visit our webinars. Before we get started, I would like to remind you about the Cochrane Rapid Review definition. This is the definition. It builds on our previous definition that we published in 2021 and is combined with the results from a project that was conducted in Ireland, where also different knowledge users were involved. And the definition says that a rapid review within Cochrane is a type of evidence synthesis that brings together and summarizes information from different research studies to produce evidence for people such as the public, healthcare providers, researchers, policymakers, and funders in a systematic, resource-efficient manner. And this is done by speeding up the ways we plan, do, and share the results of conventional structured systematic reviews by simplifying or omitting a variety of methods that should be clearly defined by the authors. And the focus of today will be what can we do to be more efficient in organizing the team and planning the review, and simplifying or omitting several steps throughout the process. Why do I focus on these steps? So basically, the rapid review process is the same as the systematic review process. And we did a scoping review in 2021 that showed that the most resource-intense steps of the systematic review process are study selection, data extraction, and risk of bias. And we also found out that tasks around administration and project organization can be very time and resource intense, but are often not in the focus of any planning or making the process more efficient. Another reason why these steps are very important are they are error-prone and subjective, and this is especially relevant if these steps are conducted by one person alone. And in traditional full systematic reviews, the best practice is that two people independently do study selection, data extraction, risk of bias. But within the rapid review, there are certain accelerations and abbreviations, and one could be that a proportion of these tasks are done only by one person. So these accelerated methods, they can increase efficiency, but they can also have negative impacts, and that's why we need to use them carefully. The recommendations and tips that I will talk about today are based mainly on these two publications. One is the publication with the same title, published in BMJ EBM. And the other one is the updated rapid review methods guidance from Cochrane. So we published the first version of the guidance during the start of the corona pandemic. And in the meantime, we did a formal evaluation of the methods guidance, which was led by Ursula. And we updated the guidance, which is currently in the peer review phase, and hopefully will be published within the next weeks or months. But this is basically the foundation of the next recommendations. Well, okay, the first thing I would like to talk more about is team considerations. So when you do a rapid review, it is very helpful to have an experienced team, which means that you have people in your team that have experience with systematic review conduct. Because rapid reviews may seem the easier to conduct than systematic reviews because they are perceived to have less methodological rigor. However, in our experience, the review team must include sufficient systematic review methodological experience to properly plan and conduct and also analyze and report the rapid review, and to be aware of the potential limitations due to the methodological shortcuts. There are also studies showing that people with less experience in doing study selection and data extraction might introduce more errors to the process than more experienced people. So it's always good to have a mix of people in the team and not only beginners. Regarding the team size, it's ideal to have a moderate number of people in your team, not very large teams. We recommend to have ideally 3 to 5 people, but it depends a little bit on the task because, for example, if you have a very large scope in your rapid review and a very tight timeline, it might be useful to have some steps where you have a large team, for example, study selection, and 10 people select the thousands of abstracts, but you have a smaller team for other steps like data extraction, where consistency is more important than, for example, in other steps. We at Cochrane Austria, we have 3 rapid response services. One is targeted to physicians, one to nurses, and one to the lay public. And we have small teams who do all the rapid reviews for the target group. So for the nurses, for example, for this rapid review service, we have 3 people. It's always the 3 people, and this increases efficiency. If you need to conduct rapid reviews on a regular basis, it is helpful to have the same people working together, because then they have a good way of communication, they know all the standard procedures, and they are very well aligned in the working process. We also recommend to use collaborative platforms or systematic review tailored software. So collaborative platforms, I'm pretty sure everyone is using nowadays, like Google or Teams, Microsoft Teams. It helps you to work simultaneously on the same document, and it also facilitates communication. And there are also lots of systematic review tailored software that can be very helpful for rapid review conduct too. Because it also allows working in parallel and from all over the world. And it also stores all the documents and makes the process transparent. Another thing that helps with the organization of a rapid review is parallelization of tasks, so that you do not perform the different tasks of the review process consecutively, but you, for example, part of the team is still doing abstract screening, and the next part of the team is already doing full text screening, and maybe another part of the team is already starting to extract the data from the full text. So this can also increase the speed of your review process. Another practical tip is that when you do extract data from studies and you assess the risk of bias of studies, you use the same person doing both at the same time, because basically the person reads the study, and then it's easier to do these 2 steps at the same time, because you don't have to read the study again when you do it as the second step. And it's also helpful to have a direct line of communication. So if you work in offices on site, it's helpful if the people working on the same review maybe share an office or can easily communicate. And if you work online, it's helpful to have, for example, Microsoft Teams chat or Slack or whatever, where you can ask questions immediately, because it can be a time saver if there are misunderstandings and they are discussed early on in the process, and people make the correct decisions afterwards, instead of waiting for a meeting that is planned during the week and maybe making wrong decisions in the meantime. For example, when you do study selection, you usually have eligibility criteria where you decide whether to in or exclude an abstract. And if there are some unclarities, it is more helpful to discuss them immediately, instead of maybe being over-inclusive just to be safe and produce a lot of backlog for the full text review. This, what you can see here, is an example of how we organized a rapid review that we needed to complete within a week. When I say we, I mean the team from Cochrane Austria. And we were commissioned by WHO to do a review on the effectiveness of quarantine during the beginning of the corona pandemic. We had 1 week time. And as you can see, we had a large team, and we had many people in the team that were very experienced with systematic review conduct, and only 2 students who were new to the process. And we did a lot in parallel, and always some part of the team were some steps ahead, preparing the next step of the review process. And as you can also see, the teams were not always at the same size because, for example, abstract screening, we put all the manpower into this process, but synthesis and grade was only conducted by 2 people to increase consistency. Well, so these were some tips for organizing your team and the process. Another tip is that you always pilot the steps like study selection, data extraction, and risk of bias assessment. If you employ a piloting exercise, it helps the team members to test this task on a small proportion of records and ensures that all team members perform this task consistently and correctly. It ensures a common understanding and reduces error, and although it costs time in the beginning, it will save you time later in the process. And how does this piloting work? So usually, for example, if you pilot the study selection on title and abstract level, you choose 50 or 100 abstracts. It depends a little bit on the amount of records that you identified within your search. And then all people who will participate in study selection screen the same abstracts. And then you see where do the people agree, where do they disagree, and all the abstracts where people disagree are discussed within the team. And this helps you to see, okay, we don't understand the eligibility criteria all in the same way. And this is an important step to ensure that everything goes smoothly afterwards. What you can see here is an example of study selection form. So in our team, we usually prepare such a form and we use it besides the software that we use for study selection. And it's like a guide that guides you through the abstract screening. So first of all, we say which studies are included. In this case, this is also from the quarantine review. We were only interested in research articles, and we excluded books, letters to the editors, or editorials. And as soon as an abstract was anything of this kind, it was a clear exclude. Then we defined the study population of interest. We also defined what should be the focus, the intervention, what would be an eligibility study design. In this case, we included basically everything except case reports. And this was very short for the abstract review, and we had more specific criteria for the full text review. You do not specifically need such a study selection form. It is also sufficient if you describe the eligibility criteria in enough detail in your study protocol, or if you enter this information to the software that you use for study selection. But it's necessary to clearly define in- and exclusion criteria so the team knows which abstracts to in or exclude. For study selection in general, there are different ways how to accelerate the process. So for a traditional full systematic review, study selection should be done by 2 people independently. And if you only find a small amount of records for your rapid review, you can also do it dually and independently. But if resources do not permit, then there are several ways how you can accelerate the process. So you can reduce the number of human judgments involved. You can use supportive software, and you could also use crowdsourcing. What do I mean when I say reduce the number of human judgment? So the recommendation of the Cochrane Rapid Review Methods group is that you screen only a proportion of records at abstract and title level dually. Then you check the agreement within the team, and if it's good, then you can continue with single screening. We defined the good agreement as a kappa of 0.8. And I have to say, this is not an evidence-based recommendation. This is an experience-based recommendation, and it depends a little bit on the topic. But that's why we recommend to check the agreement, because if you see that your team has very good agreement and you feel safe to move on with single screening, then it's probably okay. But if you see that the agreement is very bad and people are not really on the same page, maybe because the topic is very complex, then it's better to screen another proportion dually and check agreement again, and so on and so on. If the search yields small number of records, I already said consider dual and independent screening. And we recommend the same approach for abstract screening and then for full text screening. There are also other abbreviations that you could apply. For example, you could exclude obvious abstracts by one person. An obvious exclude would, for example, be an abstract where it's clearly the wrong population. If you are interested only in adults and in the abstract you see it's in small children, then it's a clear exclude. And probably the risk of missing an important study is low. And you could then screen dually the rest of the abstracts. You could also do single screening of all abstracts and let a second person check all the excludes. But this in real life actually is not really a good time saver. So we as a Cochrane Rapid Review Methods group do not specifically recommend this approach. And we do not recommend only single screening of abstracts because there are method studies showing that a relevant proportion of studies is missed by this approach. And especially if the topics are complicated or complex, the risk is too high. So we do not recommend this. We highly recommend that you use supportive software as you would use for systematic reviews, probably. There is a collection of software tools. You find it under systematicreviewtools.com. And there are several applications that have artificial intelligence incorporated. For example, Abstracker, Distiller, Epi Reviewer, Pico Portal, Rayan, Robot Analyst, Swift Active Screener, and many more. And what they do is they, based on the decisions of your team, they learn which abstracts are probably relevant for the topic and which are not. And then they rank the next abstracts by relevance. You can use this artificial intelligence help, for example, by moving. So if you have this ranking in place and you find the most relevant abstracts early in the phase, you can move them early to full text screening and let another part of the team move on with the next step. Or you can also use it to make part of the study selection automatically. So you apply, for example, a stopping rule and say, well, probably all the rest of the abstracts are irrelevant and we exclude them without having a human to judge. There are no safe stopping rules that I can recommend. I mean, there is empirical evidence that a predicted inclusion rate of 95% corresponds to finding around 98 to 100% of the relevant references during title and abstract screening, but it depends again a little bit on the topic. And artificial intelligence works, for example, better in easy topics where the focus is on drugs or easy interventions, but with complex interventions, it is not that reliable yet. So you can use semi-automation, which means that you use this ranking, but you also have a human making decisions, but full automation is not working well yet. Another approach how to accelerate the study selection process is crowdsourcing. Crowdsourcing means that you outsource tasks to a large community of people. And Cochrane has the Cochrane Crowd with the Screen for Me service. We already used it for our rapid review on quarantine. It performed well on several rapid reviews, and the sensitivity of the Cochrane Crowd was really good. It was 94 to 100%. And the crowd completed abstract screening within 48 to 53 hours, which was really fast because there were several thousand abstracts to screen. The only minus is that the crowd currently is only available to authors of Cochrane reviews, but there are also other crowd services like Amazon Mechanical Turk. But it's quite difficult to manage such a crowd, train the crowd in the eligibility criteria, and also motivate them. So it's not that easy to implement if you're not familiar with crowd sourcing. So common pitfalls within study selection are that teams move on to single screening while not having enough agreement. I already talked a little bit about this. This includes two risks. You can have the risk of missing a relevant study or many relevant studies, but you can also have the risk of over-inclusiveness. For example, if you have team members who are afraid of missing a study and include everything where they are not sure, this means you have to find all the full text for these records and then screen the full text, which is very time-consuming in the next step. Another pitfall is that machine learning might not work that well with all topics, and crowdsourcing requires experience and talent in crowd management. So we were able to use Cochrane Crowd, and Anna is managing the crowd, Anna Noel Store, very well. She did a great job, but it took her some time to motivate the crowd. Okay, so the next step in the review process is data extraction. Again, here you can reduce the number of human judgments involved, and you can use supportive software. We recommend that you use one person to extract the data and one person to check at least the key data. It's also helpful if the person who first extracts the data highlight the extracted data in the paper, for example, in the PDF, because then it's easier for the second person to make the check. Another way of saving time is to limit the data fields for data extraction. For example, you really focus on the most important outcomes for decision making. This could be 3 or 4, and you do not extract any additional outcome data. Another way of saving time and resources is to build on data from systematic reviews or from data repositories. What we do not recommend is that you do single data extraction without the verification for at least the key data. So it's okay if there is no verification for data like study country or name of the authors, but key data like the definition of outcomes and the specific outcome data should be checked by a second person. This is an example of data fields that are commonly extracted. So on the study level, you extract study level characteristics like the author name, year of publication, the country where the study was conducted, study design, study duration, funding. Then usually we extract participant demographics like sex or gender, the age, ethnicity and comorbidities, and the outcome data. So the definition and how the outcome was measured, and then the specific result. And it's very helpful if you prepare a data extraction form where you really specify how the data should be extracted. So in what format, like using semicolons, colons, 1 decimal point or more, and what exactly should be extracted. Because the more precise you are in the beginning, the more time it saves you afterwards. It is very time consuming to increase consistency if there is a lot of inconsistency in data extraction in the beginning. And that is why piloting is also very important for data extraction. On the one hand, you might identify misunderstandings. So maybe people understand number of participants differently, and some extract number of people randomized, some extract number of people analyzed. And to identify such a misunderstanding, it's important to do the pilot exercise and also to see whether people extract everything in the same format. Common pitfalls during data extractions are if you use a data extraction form that is not standardized, you might have inconsistencies if you use multiple data extractors. This Inconsistencies, these are also a reason why we recommend to have not too many people do data extractions, because the more people are involved in this task, the higher is the risk of inconsistencies. Another pitfall is that a second person who verifies the data just checks if the data was correctly extracted, but doesn't check if all the relevant data was extracted. So it's important that the second person also takes a look at the original study and checks if everything was extracted that is needed. Again, we highly recommend to use supportive software. Most helpful are tools that allow data sharing across the review process, because it's of course more helpful if you extract the data to a software where you can also use this extracted data later on for analysis, and you don't have to pull data from one tool into another tool to analyze it. There are tools that assist the review teams with data extraction. They detect specific words, they highlight data items. Full automation does not exist yet, but I would like to talk about the promising proof of concept study I was involved. It was led by Gerald Gatlehner, and they used one of the large language models that we are also already used now, like ChatGPT. But in this study, they used Claude 2, and the large language model extracted data, and it was actually very good. It had an accuracy of 96%, and it only made 6 errors on 160 data items. So this might be something that could be helpful in the future, but at the moment, there are no automation tools that take over the data extraction yet. So the next step in the review process is the risk of bias assessment. Again, here you can reduce the number of human judgments involved, and you can use supportive software. We recommend that you use a study design specific risk of bias tool. You can use a less complex tool over a more complex tool. For example, if you include randomized controlled trials, you could use the risk of bias tool, the older risk of bias tool, instead of the 2.0, because it is a little bit easier to implement. You could limit the number of outcomes for outcome level specific risk of bias assessment, and you can, like in the other steps, let one person assess the risk of bias and the second person check the risk of bias assessment, instead of having two people doing this independently. We do not recommend omission of risk of bias assessment because it gives important information for the reader. It is necessary to know whether the studies you include in your rapid review have a high risk of bias or not. And it would be, it's not very helpful for the reader if you do not assess the risk of bias at all. What you can see here is a list of risk of bias tools recommended by Cochrane. So these tools are specific to different study designs, and depending on what study designs you will include in your rapid review, you might need to use one or more risk of bias tools. And also for this step, we recommend that you use supportive software. There are also machine learning tools available, like the robot reviewer. I'm not sure if you have came across it yet. It's working quite well for randomized controlled trials. The only problem is that it uses still the old risk of bias assessment tool of Cochrane and not the 2.0. And full automation for risk of bias assessment does not exist yet. I found one study that also assessed how large language models can help in risk of bias assessment, or even can take it over. And in this study, the large language model, I think they used ChatGPT, didn't perform very well. And the authors recommend that systematic reviewers avoid ChatGPT to perform the risk of bias assessment. We will see if future studies will show different results, but at the moment, it doesn't look like risk of bias assessment will be done by large language models soon. Okay, so as a take-home message, I would like to summarize that when you form your team, make sure that you have systematic review experience within your team, because a rapid review is not an easy type of review. It requires experience to be sure what potential risk of bias you introduce by accelerating several methods. Piloting is an essential step, and it's relevant for all steps like study selection, data extraction, and risk of bias assessment. I also want to emphasize that it's not necessary to employ all the shortcuts. You could employ shortcuts for one step, but you might not think it's necessary for another step. For example, if you have thousands of records to screen, of course, you implement shortcuts. But if you only include finally one study, you could do the traditional full systematic review methodology, because one study is doable to extract and do risk of bias assessment dually and independently. And I also want to say, don't be discouraged by increased workload when using supportive software for the first time. There is a learning curve, and many things that I mentioned today might be a little bit time consuming in the beginning, but they pay off later on in the process. And as soon as you do more than one rapid review, it makes sense to invest a little bit time in these things. Okay, before we move on to questions, I just wanted to say that today I talked about a topic that is already published in the BMJ Evidence-Based Medicine series. We, as the Cochrane Rapid Review Methods Group, prepared a series where 4 papers have already been published. One is about knowledge user involvement, one about literature search, and another one about certainty of evidence rating. And 6 other topics are coming soon. One will be about appropriateness. When is it appropriate to do a rapid review? One is about synthesis within rapid reviews. One specifically about supportive software. One will address reporting. And then we have 2 special papers, one about rapid scoping reviews and one about rapid qualitative evidence synthesis.